Dimensions are classified into base or fundamental quantities and derived quantities. Velocity, I know it is LT to the power minus 1. Square bracket is always important. Divided by time is T. We are equating the physical quantity with its dimensional formula. So this is what we call it as dimensional equation. You cannot calculate the dimension of a numerical value using a dimensional analysis. Hello everyone, I am Nishma Nanjamma, Faculty of Physics in Vidhyaashram Pre-University College, the Temple of Excellence. Once again, welcome back to Session 5 on Chapter 2, Units and Measurement. So far, we have completed 4 sessions where we have come across what is units, measurement, what are physical quantities, what are the 2 categories in physical quantities, what are errors and types of errors, and significant figures and measurement of length, mass and time. In today's session, we shall study what do you mean by dimension, what are dimensional analysis, and we'll also study what is the dimensional formula for physical quantities, how do we write the dimensional formulas for the physical quantities, and we shall see the limitations and uses of this dimensional analysis. So, to begin with, let us start from what is dimension. So, what is dimensions of physical quantities? So, dimension describes, dimension explains the nature of physical quantities. So, let's begin with the definition. Dimension of physical quantity are the powers to which the base quantities are raised to represent that quantities. So, I'll repeat. Dimension of physical quantity, what do you mean by that? Are the powers to which the base quantities or the fundamental quantities are raised to represent that quantity. So, I have already explained in my previous session what do you mean by physical quantity. Physical quantity are the quantity that can be measured. So, we know there are 2 categories, fundamental quantities, or also you can call it as base quantities, and derived quantities. There are 2 type of categories, and we know physical quantities are large. They are categorized into 2 branches. If you have not watched my sessions on physical quantities and its categories, please do watch before you come to session 5, because to understand dimensional analysis, we need to know what is physical quantity and what are base quantities and what are derived quantities. So, dimensions of physical quantities are the powers to which the base quantity or the fundamental quantity are raised to represent that quantity. You mean that to represent the dimension of this physical quantity. For example, we know physical quantity, length, mass, area, volume, all are the physical quantities. Let me take the example of area. I want to calculate what is area. So, area, what is the formula for area? It is length into breadth. So, length into breadth. Length into breadth is nothing but 2 lengths. It is measured in terms of lengths. So, you will write it as length into length. Length into length is nothing but length square. Correct? Length square. So, look at here. Area is length into breadth. Length into breadth is written as L into L. Length is dimensionally represented as L. Mass is represented as M. Time is represented as T. Similarly, length into length is length square. So, what is length here? Length is a fundamental quantity, or you can call it as a base quantity also. So, the base quantity raised to power, you can see L square raised to power, length is raised to 2. So, fundamental quantity raised to power which represents that quantity. So, L square is what? L square is representing area. What is area here? Area is a physical quantity. When you talk about dimension of physical quantity, you will use a square bracket. Why square bracket is used? Using the square bracket, round a quantity, using a square bracket round a physical quantity means that we are dealing with dimension of the quantity. So, I want to calculate dimension of this physical quantity. Area is a physical quantity. If I want to calculate the dimension of the physical quantity, we represent it using square bracket around the quantity. That is equal to length into breadth. L into L is L square. So area is represented as L square. So fundamental or base quantity raised to power to which the base quantity are raised. Fundamental quantities or base quantity is raised to the power to represent this dimension of the quantity, to represent this quantity length, that is the fundamental quantity or the base quantity is raised to the power. Or take the example of volume. Take the example of volume. What is volume? Length into breadth into height. Length into breadth into height. So it is nothing but equal to 3 lengths again. It's measured in terms of length. L into L, which is given by L cube, which is given by L to the power 3. Length is what? Again, it is a fundamental quantity, or you can call it as base quantity. A fundamental quantity or a base quantity raised to power in order to represent this physical quantity, in order to represent this particular dimension of the physical quantity, volume. To represent this physical quantity, the fundamental quantity is raised to the power. This is what the definition of dimensional analysis means. You can see here, volume, you don't have M and T. In mechanics, the physical quantities is represented using the 3 terms, L, T and M usually, L, T and M. So there is no M and T here. That means M is 0, L you have 3, T is 0. You can write it this way also. This way or this way, both are right. It is, volume is independent of mass and time. It has 3 dimensions in length. It has 0 dimension in mass, 3 dimension in length and 0 dimension in time. Similarly, you can write this as M0, L2, T0. Always represent the dimension inside the square bracket. It has 0 dimension in mass, 2 dimension, it possesses 2 dimension in length, 0 dimension in T. This is also right, this is also right. It doesn't depend upon mass and time. So, dimension of a physical quantity are the powers to which the base quantity are raised to represent that particular quantity. We use square bracket to represent when we talk about the dimension of physical quantity, we use the square bracket around the physical quantity. So, all physical quantities represented by derived units can be expressed in terms of some combinations of 7 fundamental or base quantities. In my previous session, I have discussed about the 7 base quantity, what are the derived quantities and what are the 7 base quantities. So, please do watch my previous session, so that will help you to understand dimensional analysis much better. So, all physical quantities represented by a derived units can be expressed in terms of some combinations of 7 fundamental or base quantities. So, in this slide, we studied what is dimensional analysis. What is dimensional analysis? Dimensional analysis of a physical quantity area. I have taken an example of area, which is a physical quantity. So, dimension of physical quantity are the power to which the base quantities are raised, are the power to which the base quantities are raised to represent this physical quantity. So, we use square bracket whenever we talk about a dimension of physical quantity. We want to calculate dimension of volume. It is represented inside a square bracket. You want to calculate dimension of acceleration. It is represented inside a square bracket. So, next, here you can see dimensions are classified into base or fundamental quantities and derived quantities. Derived quantities means it is derived from the fundamental quantities. These are the 7 fundamental quantities. From these 7 fundamental quantities, we are deriving the derived quantities. Like derived quantity examples are area, volume, force, etc. And 7 base quantities. These are the 7 dimensions of physical world. We can call these as 7 dimensions of physical world. We have length. Length is given by You can see this is dimension to represent length. That's why in the previous slide, I had written area as L into L inside a square bracket. So, length is represented as L. Mass is given by M inside a square bracket. Time is given by T. Electric current is given by A. Thermodynamic temperature is given by K, and luminous intensity is given by CD, and last, amount of substance is given by MOL. So these are the 7 fundamental quantities which can be called as 7 dimensions of physical world. You should remember how are the representations given for length, mass, time. So next here you have derived quantities. Derived quantities, using the base or fundamental quantities, we derive the derived quantities. For example, area is a derived quantities. Area is what? Length into breadth, nothing but length into length. Length is a fundamental quantities. So using fundamental quantity, we derived a derived quantity area. So remember the representations for length, it is L, M, T, similarly A, K, C, D and mole. So you should know how length is represented in dimension. So next we'll calculate the dimensional formula. We'll calculate the dimensional formula for a physical quantities. We know there are many physical quantities. So let us calculate what is the dimensional formula for few of them. Okay, first one, in the previous slide we saw how we calculate area. Area is equal to length into breadth, that is equal to how length is represented. We saw in the previous slide, it is capital L within the square bracket. Again, breadth is also given in terms of length. So 2 length is equal to length raised to power 2, length square. So how do you represent it? This is for area. What about volume? So second one, if you consider volume, area should be given within the square bracket. If I am talking about dimensional formula of physical quantity, it should be within the square bracket. Next I have volume. How will you calculate volume? It is length into breadth into height, nothing but all are given in terms of L. So L into L into L. So it is 3 length. It is nothing but equal to L. L to the power 3. You have 3 lengths, L into L into L. So volume is independent of mass and time. So it possesses 3 dimension in length. You can also write this as it is independent of mass. It has 3 dimension in length and it is 0 dimension in time. It is independent of time. Both way are correct. Similarly, you can write this as it don't have M, so 0 dimension in M. L it is raised to power 2. T 0 dimension in time. You can write it this way also. Next, third, how do you calculate velocity? How do you calculate velocity? Velocity, what is you should know the formula to derive the dimensional formula. Mainly you should know what is the formula. What is the formula for velocity? You should know the formula, then only you can calculate dimensional formula. Velocity is displacement by time. What is velocity? It is displacement by time. It is easy to calculate dimensional formula, isn't it? Displacement is given in terms of L. It is length. Displacement, distance are nothing but length, L. What is time here? Time is represented by capital T within the square bracket. So when in the denominator you have T, when it goes to numerator, what it will become? T to the power minus 1. So L T minus 1. L T minus 1. So this is the representation for velocity. When the denominator goes to the numerator, it will become Lt to the power minus 1. You can also write this as m0 Lt minus 1. That means velocity possesses 0 dimension in m, 1 dimension in L and T to the power minus 1 means minus 1 dimension in T, time. So similarly, you have fourth one. How do you calculate acceleration? How do you calculate acceleration here? What is the formula? What is acceleration? Change in velocity. So you can write it as velocity by time, change in velocity by time. So you know what is velocity here? You have already got. It is nothing but m naught lt to the power minus 1, or you can write lt to the power minus 1. So velocity, I know it is lt to the power minus 1, square bracket is always important, divided by time is t. Time is t. Now how will I write this? When t is in the denominator, when t goes to the numerator, what it will be? L, t, one more, t will go to the numerator, so 1t adds up here, already minus 1 is there, another t in the denominator goes to numerator, means again minus 1, minus 1, minus 1, so it is t to the power minus 2. It possesses 1 dimension in length and acceleration possesses minus 2 dimension in time. So that is acceleration. Fifth one, how do you calculate density? How do you calculate density? Density is what? Previous session we have calculated, we have solved numericals on density. Density is, you should always know the formula. Without formula you cannot derive dimensional formula for physical quantity. It is mass by volume. So what is mass here? Mass is represented by capital M with square bracket. So mass is M divided by what is volume? You have calculated what is volume? L to the power 3. When denominator goes to the numerator, what you will get? It is again M L to the power minus 3. So density possesses 1 dimension in mass and minus 3 dimension in length. It possesses 0 dimension in time. There is no role of t here. So you can write t to the power 0, or this representation is also right. When the denominator goes to the numerator, it will be L to the power minus 3. So this is how you calculate dimensional formula for physical quantities. If you know what is velocity, acceleration, if you know this, you can calculate dimensional formula easily for the physical quantities. Similarly, you have many physical quantities. I have tabulated few of the physical quantities. Area, I showed you how you derive the dimensional formula, how you obtain the dimensional formula. Area, density, acceleration, velocity. Similarly, you can calculate by force. Force, you should know what's the expression. Force is ma, mass into acceleration. Mass is m. Acceleration we have already derived. If you substitute, you will get what is the dimensional formula for force. Similarly, work, power, pressure, frequency, volume. There are many physical quantity. I have tabulated few of the dimensional formula of physical quantities for you. Similarly, how I have calculated for area, volume, velocity, acceleration and density, you can try to calculate the dimensional formula for rest of them, force, work, pressure, etc. So, go through this table. Next, you have dimensional formula and dimensional equation. What do you mean by dimensional formula and dimensional equations? Both are different. Dimensional formula, what do you mean by that? So, volume is given by, I have derived the dimensional formula, m to the power 0, L to the power 3, T to the power 0. So, this is the dimensional formula of volume. So, this expression, this m naught L 3 T power 0 within the square bracket, this is the expression to show how and which of the fundamental or base quantities combine to give the dimensional formula of volume. Similarly, you have velocity. You can see this is the expression for dimensional formula for velocity. How and which of the fundamental quantities have combined to give the dimensional formula of velocity, dimensional formula of this physical quantity. So, I'll read the definition, just go through it. The expression which shows how and which of the base quantity or fundamental quantity, which of the base and fundamental quantity represents the dimension of the physical quantity. The expression MLT is an expression. Expression which shows how and which of the base quantity. So, how and which of the base quantity here? Mass, length and T. They are the base or fundamental quantities. That is representing the dimension of a physical quantity, volume. So, this is what you mean by dimensional formula. Then what do you mean by dimensional equation? Dimensional equation. So, velocity is given by V. It is represented by symbol V. V is equal to, it is given by, velocity is given by V is equal to m naught L T to the power minus 1. So, equation, this is the equation obtained by equating the physical quantity with its dimensional formula. The equation, this is an equation. The equation obtained by equating physical quantity with its dimensional formula. Similarly, volume given by V is equal to, what is the expression for volume? It is m naught L3 T to the power 0. So, this is an equating. We are equating the physical quantity with its dimensional formula. So, this is what we call it as dimensional equation. Formula is expressing, it is an expression which of the base quantity is representing, which are the base quantities that is representing the dimension of the physical quantity, say volume. So, equation is nothing but equating the physical quantity with its dimensional formula. So, this is dimensional formula and dimensional equations. Next, you have applications of dimensional analysis. What are the uses of this dimensional analysis? Why should we study this dimensional analysis? What is the purpose? So, the first point is to check the correctness of the equation. To check the correctness of the equation, whether the given equation is dimensionally equal. To check if it is equal, then that equation is dimensionally correct. If a given equation, when we test the dimension of the given equation, say for example, I have S is equal to V naught T plus half AT square. This is an equation. This equation is dimensionally correct. How will we check? If the LHS, dimensions of LHS and RHS are equal, then we say this equation is dimensionally correct. If LHS and RHS are dimensionally equal, then we say this equation is dimensionally correct. To check the correctness of the equation, we'll come to that in our next slide. We'll check correctness of few of the equations. So next, to convert the unit of physical quantity, from one system to another. That is, to convert the unit of a physical quantity means to convert from CGS, we use FPS, all this MKS. So, to convert the unit of physical quantity from one system, from CGS to FPS or CGS to MKS, one system to another. Third, we have deduce the relation connecting the physical quantities. Deduce the relation connecting to the physical quantities. We'll solve a numerical based on the third point in our upcoming slide. So, next is accuracy of the equation, or dimensional consistency can be tested. Dimensional consistency, accuracy can be tested using the dimensional analysis. So, these are the applications. How we have applications, similarly we will have limitations. If we have the uses, obviously we will have any advantages, similarly we will have disadvantages. So, we have applications of dimensional analysis. We will also look at what are the limitations of this dimensional analysis. To what limit you can use this dimensional analysis. And I want to mention a note here. You cannot calculate the dimension of a numerical value. Note, important, keep in your mind, note. Keep in your mind this note. You cannot calculate the dimension of a numerical value using a dimensional analysis. You have volume, you can calculate, square bracket indicates what? Dimension. You can calculate dimension of volume, but you cannot calculate a numerical value, dimension of a numerical value. If you have a numerical value, you cannot calculate the dimension of this numerical value using dimensional analysis. So, next, you have dimensional consistency of equation. In the uses of dimensional analysis, we know one of the uses of dimensional analysis is dimensional consistency, testing the dimensional consistency, checking the correctness of the equation. This slide is related to the first point of our uses of dimensional analysis. So what do you mean by principle of homogeneity of a dimension? Principle of homogeneity of dimension. What do you mean by principle of homogeneity of dimension? So what do you mean by homogeneity? What does this term mean here? Homogeneity means uniformity, sameness, to be same. Homo means same, uniform. So principle of homogeneity of dimension. So we'll go through the what is the principle is all about. The magnitude of the physical quantities may be added together or subtracted from one another only if they have same dimensions. Only if they have same dimensions. That is what we mean by homogeneity, uniform or remaining same. So principle of homogeneity, same. Homogeneity means same, being same. Homogeneity of dimension states that a magnitude of a physical quantity can be area, length, volume, mass, etc. So the magnitude of a physical quantity may be added or subtracted from one another only if they have same dimensions. In other words, you can add or subtract a physical quantity which has same dimension. You cannot add velocity with force, or you cannot subtract electric current with a temperature. You can either add or subtract a physical quantity only if they have same dimensions. So look at this example. I have considered an equation here. X is equal to V naught t plus half at square. Now what I should do? I should check the correctness of the equation, whether it is dimensionally correct. So what I'll do to solve further this equation, you should know the terms here. What do you mean by X here? What is V naught? What is T? What is at square? You should know all the terms. X here is nothing but the displacement. You know displacement is given in terms of L, measured in terms of length. So X is your displacement. V naught is the initial velocity. X is the displacement. V naught is the initial velocity and T is the time and A is the acceleration. A is the acceleration. So if you know what are the terms, you can substitute the dimensional formula for those. So we should see whether the LHS is equal to RHS. If the LHS is equal to RHS, then the equation is dimensionally correct. So dimension of X. What is the dimension of X here? X is what? Displacement. So displacement is given in terms of, look at here, displacement is given in terms of L. Correct? L1 means there is no mass and T coming in displacement. So you can write it as M0 or T0. Both the way are right. So what is V naught? V naught is nothing but the initial velocity. So what is the dimensional formula for velocity? What is the dimensional formula for velocity? We calculated it. Lt to the power minus 1. What is the dimensional formula for acceleration? Lt to the power minus 2. Oh, consider these two. So, substituting, you'll get, velocity? It is Lt to the power minus 1 and time, it is represented by capital T plus you have half at square. A is what again? Acceleration. Dimensional formula is Lt to the power minus 2. We have solved the dimensional formula for physical quantity in our previous slide. So go through what is the dimensional formula for acceleration here. It is Lt to the power minus 2 and have T square. So I'll write it as T square. Now substituting, I have L in the RHS is equal to T and T gets cancelled here, minus 1 and plus 1. It gets cancelled. So I have length plus half, again minus 2 and plus 2. T square I have, T square, and Acceleration has in the dimensional formula has -2. So this and this get cancelled and again L is remaining. I have given a note in the previous slide that numerical value, dimension of a numerical value cannot be calculated using dimensional analysis. So this we will be neglecting. We cannot calculate. So it is L is equal to again L. You can see we have L in all the terms. L in all the terms. LHS has L and RHS as L. So what does this mean? LHS is equal to RHS. That means my equation is dimensionally correct. It is dimensionally correct. It is dimensionally correct. LHS is equal to RHS. So, equation is dimensionally correct. It is verified. Here you can see I have solved. Similarly, I have example 2. I have taken one more equation like the previous one. Half mv square is equal to mgh. So, the dimension of LHS should be equal to RHS. If it is equal, we say the equation is dimensionally correct. If it is not equal, then it is dimensionally incorrect. So, according to principle of homogeneity, it has to be equal. Then only if the dimensions are equal, then we can add or subtract the physical quantity. According to the principle of homogeneity, we can add or subtract a physical quantity if they are dimensionally same, if they have same dimension. So, if they have to be dimensionally correct, then LHS should be equal to RHS when we test the equation. So, here what is M? You should know the terms. What is M? M here is mass. What is V? It is velocity. It is velocity. What is G here? Acceleration due to gravity. G is acceleration due to gravity, and H is nothing but height. H is height, M is mass, velocity, acceleration due to gravity. It has a dimension of acceleration, LT to the power minus 2, LT to the power minus 2. So, now let us take the dimensional consistency of the equation. LHS should be equal to RHS. What is there in LHS? Half mv square. Half we know, we cannot find the dimension of a numerical value. So, leave the half mv square. What is M? Mass is given by capital M. V square. Velocity we know it is L t to the power minus 1. So, L t to the power minus 1 square is there. So, what it will become? It is M L square t to the power minus 2. I am multiplying, it is square and velocity is square. So, by squaring I have L square t to the power minus 2. This is the dimension in the LHS of the equation. Now, let us take the dimension in the RHS, whether it is equal or not. So, RHS, if I consider mgh, what is M here? It is mass given by capital M. What is G here? G is acceleration due to gravity. What is the acceleration? Dimensional formula L t to the power minus 2. So, if I substitute L t to the power minus 2 and you have L here. So, how did the L come? Height is nothing but measured in terms of length. Length into breadth into height. In case of volume, it will be L cube. So, height is measured in terms of length itself. So, again it is multiplied by L. So, after multiplying by L, you will get L square t to the power minus 2 remain as it is. So, your answer will be M L2 t to the power minus 2. T to the power minus 2. So, it is L t to the power minus 2 into it is L. So, you will get M L2 t to the power minus 2. You can see the dimension here. You can see here. They are same. So, LHS is equal to RHS. So, the dimension of LHS and RHS are same. The dimension of LHS and RHS are same. Hence, the equation is dimensionally correct. This is how you test the dimension consistency, the correctness of the equation. So, these are the two equations I have considered. You have to check whether the RHS is equal to LHS. If RHS is equal to LHS, if the dimensions are same, then it is dimensionally correct. This is one of the application of dimensional analysis. This is one of the application of dimensional analysis. Next, you have defects of dimensional analysis, the disadvantage of dimensional analysis. Whenever you have advantage, it's quite obvious that you'll have disadvantage of dimensional analysis. Let us go through this. While deriving the formula, the proportionality constant cannot be found. While deriving the formula, the proportionality constant cannot be found. I have told you, if there is a numerical value, you cannot find out represent the numerical value using dimensions. So, you cannot find the dimension of a numerical value using dimensional analysis. The equation of physical quantity that depends on more than 3 independent physical quantities cannot be deduced. The equation of physical quantity that depends on more than 3 independent physical quantities cannot be deduced. The third point is this method cannot be used if the physical quantity, this method cannot be used for if the physical quantity depend on more parameters than the number of fundamental quantities. So what this method is telling, this method cannot be used if the physical quantity is depending on more parameters than the number of fundamental quantities. What is the fourth point, fourth defect? The equations containing trigonometric functions and exponential functions cannot be derived. If your equation consists any trigonometric functions or any logarithmic functions or exponential functions, then you cannot deduce them. You cannot use dimensional analysis. The equation containing trigonometric function, exponential function or logarithmic function cannot be derived. If that equation has these functions, then using dimensional analysis you cannot derive them. So go through, these are the 4 defects of dimensional analysis. You have seen what are the uses of dimensional analysis and you have defects of dimensional analysis. Next, deducing you have read the third point in the uses of dimensional analysis in the previous slide. What is the third point there? The third point was deducing the relations among the physical quantities. So, the physical quantities are given here, gravity is given, mass of the bob is given, length is given. The physical quantities are given, you have to derive the expression for them. This is one of the uses, one of the application of dimensional analysis. So, I am solving the numerical for that. How we deduce the relation among the physical quantities, length, mass, acceleration, etc. So, let us read the problem. Consider a simple pendulum. Consider a simple pendulum having a bob attached to the string that oscillates under the action of force of gravity. Suppose that the period of oscillation of simple pendulum depend on its length, mass of the bob and acceleration due to gravity. Derive the expression for the time period using method of dimensions. We know what is the formula for time period of oscillation. We have solved many numerical based on time period of simple pendulum in the previous sessions. So, how will you calculate it? Is T is equal to 2 pi root of L by G. This is the expression we use to calculate the time period of oscillation of simple pendulum. We have a pendulum. So, we have a simple pendulum attached to the vertical base from where we have to calculate, we have a metal bob. So, when we oscillate this metal bob, that is oscillation is nothing but the to or froth movement of the object, to or froth movement of the metal bob. So, when we oscillate, we have to calculate the time period of oscillation. And this time period depends on length, mass and acceleration due to gravity. M is the mass of the metal bob. M is the mass of the metal bob in the simple pendulum, and A is acceleration due to gravity and L is given by length. So, they are telling time period, that is period of oscillation depends on length, mass and acceleration due to gravity of the metal bob. So, I will write it as T is proportional to M, L, G. Mass, length, acceleration due to gravity. This proportionality means it's depending. Time period depends on M, L and G. So if I have a proportionality symbol, if I have this proportionality symbol, I cannot calculate the equation for physical quantities. If I have the proportionality symbol, I cannot calculate the equation, deduce the equation for physical quantities. So what I'll do, I will bring a constant K. K is proportionality constant. So I'll bring a proportionality constant K. So K into ml G. So if I have this proportionality means nothing but it is depending, temperature and is depending on ml and G. If I have a proportionality symbol, it's difficult for me to find the expression for physical quantities. That's why I am bringing a proportionality constant K here. So I will equate it to KmlG. Now what I have to do here? You know how mass is represented? You inside a square bracket with capital M. How length is represented in the fundamental dimensions? It is L with square bracket. G is represented by acceleration due to gravity. So I'll represent it as, I want to find dimension. So that is equal to K M X L Y, and I'll calculate G is acceleration due to gravity. It is given by Z. So what X, Y, Z here are? X, Y and Z. What is X, Y and Z? They are arbitrary constant. They are arbitrary constant. They are arbitrary constant. Remember the definition of dimensional analysis. A fundamental quantity raised to the power to represent that physical quantities. So fundamental quantities raised to the power to give that particular physical quantities. That's why I have considered X, Y and Z above there, raised to the power. It need not be X, Y and Z. It can be A, B, C or M, N, O. But I have considered X, Y, Z because it is the given notation in your NCERT textbooks. So X, Y, Z are the arbitrary constant. So next let us deduce this further. So time period T is equal to K is a proportionality constant. It's a constant. So M to the power X, and what did we have here? L to the power Y, and I have acceleration due to gravity. It is given acceleration. What is acceleration? Dimensional formula. LT to the power minus 2 to the power Z. So I can write this as M X L. I have Ly Lz. So I can equate to Ly plus Z and T to the power minus 2 Z. So further on equating, I have T here. L and M is 0. L and they have 0 dimension in length and mass. So what X will be equal to 0 because there is no M here. What will be Y? What is Y plus Z? That will be equal to 0 because there is no length term here. Then what will be Z? It is minus 2Z. Minus 2Z is equal to, I have 1. I have T here, but I don't have, you can write it as M0, L0, T. You can write it this way or this way. Both are correct. It has 1 dimension in time, 0 dimension in length and 0 dimension in mass. So X is equal to 0. Y plus Z, you can see it is equal to 0. And minus 2Z is equal to 1. Time has 1 dimension. So it is equal to 1. On substituting, you will get Z is equal to minus half. You know X is equal to 0. And what about Y then? Y minus half. Z, do you know it is minus half. Plus is there here. Is equal to 0. So Y is nothing but when minus half goes to RHS, it will be plus half. It will be plus half. Now how will you solve this further? How will you solve this? So it will be M to the power X is 0. And I know L to the power it is plus half. After substitution it is plus half. And T to the power minus half. So how will you write now? How will you write? So this is mass, length, and this is the term of gravitation. So I will reduce this as, I know K is what? Constant. K has a value 2 pi. From experiments, we know K is a constant which has value 2 pi. So T is equal to 2 pi. So I can write this as T is equal to K m0 L to the power half G to the power minus half. So this will be written as like this. So K is nothing but 2 pi. From experiment we know K is 2 pi. Substituting 2 pi is equal to m is 0. So this is nothing but something to the power 0 is nothing but 1. So L to the power half. Half is nothing but root, square root. So root L into minus half. How do you write minus half? Minus half is nothing but 1 by root G. So this can be written as 2 pi. So 2 pi whole root. I have root whole root L by G. This is nothing but equal to time period. So time period is 2 pi root L by G. I have got time period is equal to 2 pi root L by G. So LK is here constant. Constant from experiment has value 2 pi, and L to the power half is nothing but square root. That is nothing but square root of L, and minus is there. That's why it is 1 by root of G. If you have minus 1 half, how will you write this? 1 by root G. So on whole I have taken root 2 pi root L by G is equal to T. So they have asked me to find what is the expression for time period using the method of dimension. This is the method of dimension. Using the method of dimension on substitution, I have last find out what is the expression for calculating time period of oscillation. This is how we deduce the expression. That is, this is how deduce the relation. We are finding the relation to calculate time period using the physical quantities given in the problem. So analyze, understand, and put out in the paper. This is how you solve the numerical. So in today's session, we studied what is dimensional analysis with example of area and volume. How do you represent dimension using a square bracket around the physical quantity. Then we studied the dimensional formula for physical quantity. I derived and showed you few of the dimensional formula for physical quantity, and few of them I have tabulated in the column in the previous slide. Next we saw what is dimensional formula, dimensional equation. What do you mean by both of them? So next we studied about the principle of homogeneity and uses of dimensional analysis. We took few of the equation and deduced and saw whether that equation is dimensionally correct or not. Similarly, we went through the defects of the dimensional analysis, that is the disadvantage of dimensional analysis. Then we came through the one of the uses of dimensional analysis says that deduce the relation using the physical quantity. We took a problem and we deduced the relation for time period of oscillation using the physical quantity given in the question. That's all for today's session. So this is the last session of units and measurement. So please go through all my sessions on units and measurement. I'll come up with more interesting physics section. Until then, take care. Have a good day. Thank you.